when software teams quietly fail, and what successful teams do differently where. Unsuccessful teams don't fail because they lack smart engineers. They fail because of how they work, arguing about code behavior instead of writing tests, bike shedding formatting instead of automating it, manually testing everything, optimizing for ego over outcomes, and never reflecting on whether any of it is working. This article walks through 8 patterns I've seen repeatedly in struggling teams and contrasts them with what successful teams do differently. If you see your team here, it's not an accusation, it's a starting point. Introduction. Every failing software team looks unique from the inside. Different products, different technologies, different company politics, but when you zoom out a bit, the patterns repeat with almost embarrassing consistency. Over the years, I've seen teams that struggle to ship, struggle to collaborate, and struggle to improve. They don't fail because they are not smart enough. They fail because of how they work, how they write code, how they review it, how they deploy it, and how they treat each other. In this article, I want to walk through the most common patterns I've seen in unsuccessful teams and contrast them with what successful teams do instead. None of this is about best practices in the abstract. It's about day-to-day behavior, pull requests, naming, tests, deployments, documentation, and culture. If you recognize your team in here, that's not an accusation, it's a mirror. Arguing about behavior in pull requests instead of proving it with tests. In unsuccessful teams, pull requests are full of conversations like, "This function doesn't handle this case." "No, it does, look at line 47. But what about when X is null?" "Yeah, but that never happens." Nobody really knows who's right because there's nothing to back it up. There are no unit tests, no clear specs, no executable examples. So the PR becomes a debate about opinions instead of a discussion about behavior. What's really happening here is that the team is trying to reason about behavior in their heads instead of encoding it as tests. Successful teams handle this completely differently. They write tests that say, in plain, executable form, "Given this input, we expect this behavior." If there's a disagreement in a review, they don't argue paragraphs in comments. They say, "Cool, let's add a test that proves your scenario and see what happens." Tests become a communication tool. They freeze ambiguous conversations into concrete examples. They act as living documentation of edge cases and expectations. They allow you to refactor aggressively without fear because you know when you break something. To be clear, tests don't magically solve everything. You can still have bad tests, missing tests, or overly coupled tests. But the absence of tests almost guarantees endless PR debates about behavior because nobody has an objective reference. If most of your PRs sound like philosophy debates about what the code should do, the real signal is you don't have enough tests. The importance of automated testing is well documented across industry leaders. Airbnb evolved from a culture where most code shipped without tests to one where untested changes are immediately flagged, reducing build times from over an hour to about 6 minutes. Similarly, Netflix runs nearly 1,000 functional tests across devices for each pull request, ensuring behavior is proven rather than argued. Bike shedding, formatting, and naming, instead of letting tools decide. Another classic sign of an unsuccessful team: massive amounts of energy are spent on formatting and naming conventions, arguments about snake case versus camel case, where to put braces, whether this should be called manager, service, controller, or thing doer. In theory, these are small details. In practice, they burn through an incredible amount of reviewer and author time when handled manually. We have tools for this. In Go, you have GoFMT and Golang CI-lint. In Python, Black and Rough. In Rust, RustFMT and Clippy. Successful teams push as much of this as possible into tooling. A formatter decides how the code looks. A linter catches common gotchas and enforces style. CI fails if the code doesn't match the agreed standards. The result PRs stop being style tribunals and start focusing on things that actually matter. Design, correctness, performance, clarity of intent. It's worth challenging a subtle belief here sometimes engineers like having strong opinions on style because it gives them a sense of control. But optimizing for personal taste is the opposite of optimizing for team productivity. Mature teams let tools standardize the boring stuff so humans can spend their energy on higher level problems. If your team spends more time talking about where to put a brace than about whether the feature actually solves a user problem, you don't have a culture issue, you have a tooling issue. This phenomenon is called bikeshedding, or Parkinson's law of triviality, coined by C. Northcote Parkinson in 1957. It describes how people give disproportionate weight to trivial issues. In software development, this often manifests as lengthy discussions about coding style, while architecture receives less attention. The solution is simple automation. Automated code formatting tools like Prettier and Black were created specifically to eliminate style bikeshedding entirely.
Preabe von mir into.
Shipping slowly because everything is manually verified. Here is another pattern I've seen over and over. Code passes linting and unit tests. It's deployed to a dev environment. Engineers manually click around. Does it work? If it looks okay, it's promoted to staging. On staging, manual tests happen again. Eventually, someone gives a thumbs up for production. Every step is slow. Every step is fragile. Every deployment feels a bit like rolling the dice. The intention is good. We want to be careful. The impact is bad. Engineers spend a huge amount of time repeating the same manual checks instead of building features or improving the system. Successful teams invest heavily in automated, end-to-end tests and robust deployment pipelines. Unit tests cover isolated behavior. Integration tests cover service boundaries and contracts. End-to-end tests cover critical flows from the user's perspective. CI/CD automatically runs all of this and promotes builds through environments. And yes, automation is expensive. You have to identify the important flows, deal with flaky tests, mock dependencies in smart ways, and keep everything maintained. But the alternative is worse human beings acting as slow, unreliable test runners. There is a subtle trap here. Teams that rely on heavy manual testing often feel more in control. They have literally seen it with their own eyes. But that feeling of control is an illusion. Humans are bad at consistent repetition. Automated tests are boring and dumb, but they are consistent and fast. If deploying to production feels like an event instead of a non-issue, you probably don't have enough automation. Industry leaders have proven the value of automation at scale. Netflix uses Spinnaker for global continuous delivery and created Chaos Monkey to constantly test system resilience by randomly killing production instances. Spotify
Toxic team dynamics, proving you're smart versus building something together. One of the most destructive traits of unsuccessful teams has nothing to do with code. It's the vibe. You can feel it in meetings, in peer comments, in Slack threads. Engineers trying to prove they're the smartest person in the room, people enforcing their personal beliefs at all costs. My way or it's wrong. Reviews used to show off, not to help. Passive-aggressive comments. As I already explained before, a general get my stuff done, the rest is not my problem attitude. The team is not one team. It's a collection of individuals optimizing for ego, not for outcomes. Successful teams look extremely different. They have a clear, shared goal. We're here to make this product better. People are genuinely happy to help each other. Code reviews are collaborative. How can we make this clearer? Not, how can I prove you're wrong? Knowledge is shared, not hoarded. Wins are celebrated as team wins. Now, it's important to challenge one belief. A healthy team is not one without conflict. Successful teams absolutely disagree, sometimes very strongly. The difference is how they disagree. They argue about ideas, not identities. They can fight over architecture and then go grab coffee together. Unsuccessful teams, on the other hand, personalize everything. A review comment becomes an attack. A technical disagreement becomes a political battle. If your team culture rewards being right over being useful, you will eventually lose your best people and keep the ones who are best at playing politics. The importance of healthy team dynamics is backed by research. Google's Project Aristotle, which studied 180 teams from 2012 to 2014, found that psychological safety is the single most critical factor in team success. Teams with higher psychological safety are less likely to leave, harness diverse ideas better, bring in more revenue, and are rated as effective twice as often by executives. The research showed that how teams disagree matters more than whether they disagree. Inventing a new project structure in every repository. In some teams, every repository feels like entering a foreign country. In one service, the business logic lives in PKG helpers. In another, it's spread across utils, services, and random internal packages. One person loves feature folders, another insists on layers, a third just shrugs and dumps things wherever. Nothing about the structure is obviously wrong, but nothing is consistent. You open a new repo and have to relearn the mental model from scratch. Unsuccessful teams underestimate how much cognitive overhead this creates. PR reviews get slower because nobody knows where logic belongs. Onboarding gets slower because there is no standard pattern, and decisions about structure are made ad hoc by whoever started the project. Successful teams deliberately choose a standard architecture and stick to it. It almost doesn't matter which one you pick, as long as you're consistent. Ports and adapters hexagonal architecture, domain-driven design with clear bounded contexts, feature-based modules with well-defined boundaries. The key is people know where things live. Where's the domain logic? Over here. Where are the HTTP handlers? Over there. Where are the adapters to external systems? In this layer. Once that's clear, you stop wasting time arguing where to put files and start focusing again on what those files do. Code reviews get faster because everyone shares a mental map of the system. If every new project in your organization feels like a completely new architectural universe, you don't have flexibility, you have chaos. Architectural patterns like hexagonal architecture, first proposed by Alistair Cockburn, provide a consistent way to organize code. Robert C. Martin's clean architecture combines principles from hexagonal, onion, and other architectures to create maintainable systems. The key insight from Martin Fowler's writing on application architecture is that consistency matters more than the specific pattern you choose. A buzz factor of 1, the hero engineer trap. Another sign of an unsuccessful team is the hero engineer. There is this one person who knows how the product really works, knows all the historical decisions and their weird trade-offs, is the only one who can debug production issues quickly, is the only one who can review certain parts of the code. On the surface, this person can look like a savior. In reality, they are a single point of failure. If they get sick, go on vacation, burn out, or leave the company, the product is suddenly at risk. Successful teams spread knowledge deliberately. Multiple people can explain the architecture. Critical areas of the codebase always have multiple reviewers who understand them. Pair programming or mob sessions are used for tricky areas. Documentation backs up tribal knowledge. The buzz factor is not just about risk, it's about speed. When only one person can unblock things, the whole team's throughput is bound to that person's availability and mood. There is a belief that sometimes emerges in struggling teams. It's just more efficient if the expert does it. That might be true in the short term, but it's a disaster long term. Every time the expert does something alone, the buzz factor goes down and the dependency increases. If your team has parts of the system that only one person is allowed or able to touch, you don't have a hero, you have a structural problem. The buzz factor, defined as the number of people who must be lost before a project can continue, is a critical metric for team resilience. Research from the Applied Software Engineering Research Group found that 10 out of 25 popular open source GitHub projects had a buzz factor of 1. The solution involves multiple strategies: pair programming, cross-training, code reviews, and comprehensive documentation.
Relying on memories instead of documentation. In a lot of unsuccessful teams, documentation is treated as optional, or worse, as a bureaucratic chore for someone else to do later. Architecture decision records, ADRs, component diagrams, runbooks for operations, onboarding guides. Yeah, we should have that at some point. So decisions live in Slack threads, in people's heads, in half-remembered meetings. New team members join and hear things like, "We do it this way because of that incident 2 years ago." What incident? Don't worry about it. Successful teams treat documentation as part of the product. ADRs capture why important decisions were made and when, and under which constraints. High-level architecture docs explain how the system fits together. Code structure and conventions are documented so new people don't have to guess. Operations have runbooks and readiness guides so incidents don't turn into chaos. Team agreements and processes are written down, not passed through gossip. Documentation doesn't mean write a 200-page wiki nobody reads. It means capture the things that people repeatedly ask about or that are painful to rediscover. A good test if someone leaves the team, how much knowledge leaves with them. In unsuccessful teams, the knowledge evaporates. In successful teams, most of it is already written down and the gap is manageable. If your team's architecture is effectively orally transmitted traditions, you're one reorg away from everyone being confused. Architecture decision records. ADRs are a proven approach to documentation. AWS's architecture blog shares best practices from implementing over 200 ADRs across projects, emphasizing that ADRs capture important decisions with context and consequences. Each ADR should define the decision's context, the decision itself, and its consequences, helping teams align and reducing recurring decision-making efforts. Never reflecting on how you work. Happy it's stressed just one more pattern that ties all of this together. Unsuccessful teams rarely step back and ask, is this working? They might do stand-ups mechanically, push tickets through a board, ship features eventually, but they don't seriously reflect on their process. They don't regularly run meaningful retrospectives. They don't track whether their changes make life better or worse. The way they work is accidental, not designed. Successful teams treat the way they work as a product too. They run retrospectives and are brutally honest about what's painful. They experiment with improvements and see what sticks. They revisit old decisions when context changes. This doesn't mean endless process churn. It means having a habit of continuous improvement, small changes, measured impact, adjust again. Without that,
Even intelligent teams slowly drift into a swamp of bad habits. Every pattern in this article tests bike shedding, manual deployments, toxic culture, bus factor 1, no doc scan creep in if nobody is actively maintaining the way of working. Regular retrospectives are central to this practice. Spotify's engineering teams use dedicated retro formats, including the Sailboat, Plus Delta, and Lean Coffee, with agile coaches helping squads continuously improve. Atlassian notes that retrospectives have been a cornerstone of Agile since 2001, enabling teams to reflect on recent work, identify improvements, and plan actionable changes that foster continuous improvement and team engagement. Conclusion from quiet failure to deliberate success. Unsuccessful teams don't usually explode in some dramatic catastrophe. They fail quietly. In PRs full of opinion battles instead of test cases. In endless arguments about formatting that a linter could solve. In slow deployment pipelines guarded by manual click tests. In toxic micropolitics and ego battles. In inconsistent project structures that waste everyone's time. In knowledge hoarded by a few heroes. In missing documentation that forces people to rediscover everything. In the absence of real reflection on how they work. Successful teams are imperfect. They still have bugs, outages, arguments, and bad days. But they do a few key things differently. They automate what can be automated. They standardize what can be standardized. They document what others will need. They share knowledge instead of hoarding it. They optimize for the team, not the individual ego. They regularly ask, is this still the best way to work? If you see your team in some of these anti-patterns, that's not a reason to feel guilty. It's a starting point. Pick one area, tests, linters, deployments, structure, culture, docs, and move it one step in the right direction. The difference between an unsuccessful and a successful team is not one big transformation. It's a long series of small, deliberate corrections. Start with one.